Well, first of all, what is Git? Git is a program that software developers use to keep track of their changes. It's open source, so you can download it for free, use it for free. It was created in 2005 by Linus Torvalds to help with managing the source code for the Linux kernel. I guess Git is managed using Git, so that's kind of interesting, very meta. Git is distinct from other source control software in a few ways. One, Git uses snapshots instead of diffs. Anytime you change a file in Git, it's going to store a snapshot of the entire file, not just the difference of the file between how it was and how it is now. It stores the entire new version of the file in its own database. Other version control software stores a diff in its database. The problem with that is you have a risk of losing your data. Whereas with Git, because every commit is a snapshot of the entirety of the files that have changed, you run a lot less risk of losing information because you have everything in each snapshot. It doesn't store files that don't change in that snapshot. It just references the prior version. There's a little bit of risk there, but not nearly as much as if you just stored a diff. The next thing about Git that's unique is that most operations are local. Some other version control software requires you to be connected to a server at all times in order for it to function. Git's not like that. Git, you can download a full version of a repository locally. That's great if your Wi-Fi goes out or something. You're not going to be stuck without being able to commit or make changes. You can do it all locally. Another thing that's unique about Git is that it has a very high level of data integrity inbuilt. Git uses something called the SHA-1 hashing algorithm to cryptographically ensure that the integrity of your commits is maintained when pushed over the network, for instance, or when you share the database. Each commit contains not only all of the files that were changed, the complete file itself, but also a hash of those files. And that hash is created using a SHA-1 hashing algorithm. And then that hash is also transmitted or stored in the database with the commit so that later on it can be compared. So you can just run that same commit through that same hashing algorithm and you should get the same output, the same digest, which is illustrated here in this graphic that you see on the screen. The next thing that's unique about Git is that nearly all Git operations add data to the database. Instead of some of them removing data, they would instead add a remove record. Instead of going back in history and deleting a record in Git, it will actually create a new record in the database that shows that the file got deleted. You could actually traverse back through history and you'd see files created, file exists, files deleted, file no longer exists. Git stores all of that and every state in between in its database. And you can find that database in any Git repo. If you go into that directory where the Git repo is stored and you go to the root of the repo and you'll see a .git directory or folder. Inside that directory is an entire database of that repository with all of the changes ever made. The next thing that's unique about Git is that it has 3 states. One state is changes in your working directory that have not been either staged or committed. So they're just there. You've made them. Git's aware that there are changes, but hasn't interacted with those changes at all. The next state is those files or those changes have been staged. And when those changes are staged, like I said, in Git, the entire file gets staged, not just the diff. In that state, Git is aware of those changes still, and now Git knows that the next time you commit, it's going to include the changes that you staged. And then the final state in Git is the changes are in the repository. And once the changes are in the repository, like we just covered, they're there and they will always be there. Even if you remove them, there'll just be a new record that shows that you removed them, but the original file that got added will be there in the history. So those are kind of the main working differences between Git and things like SVN or CVS. That's how Git is unique, by having all of those features.